this is the time to start to talk about software, the software that we are going to use this today. We are going to do practice with this software in three different sessions. You have to choose one of the three. This one of them is about Cype software in Open BIM workflow. When we talk about Open BIM, we mean working with IFC format. Okay, that is the format for BIM models. That the format that Building Smart recommend to work on. So this format is a standard format, and many software can read this model. Okay, but it's not the native format of each software. Is a format to interchange the model between software. Okay, and Cype works with this format in order to exchange information between different software. Each of one can do only one part of the design. Okay, so I'm going to show you two different workflows. One for build the BIM model and get the bill quantities, or get the quantities for the budget of the building, and the other is another workflow in order to perform the energy analysis. Okay, and now I'm going to tell you something about all the software in this workflow and which one of each are free and which one is not free. So I think I like the way of thinking of Cype, because Cype use a server called BIM Server Center. That is a server, is a cloud and a space in the cloud, free. You can use them for share information, for store information, and because this information is in IFC format, the models are in IFC format. There is this information. There is not too much. The space needed is not too much, and this server that is of Cype is free. Okay, you can use it, and Cype has all the software that they develop connected with BIM Server Center. So you can design the structure, you can model the building with the architecture part of the building, the envelope and the partition walls, with properties and information, and after that you can get the bill of quantities and also perform the energy analysis. And there are a lot of different software in this workflow, but working with the same model, okay, with the same model that is this model has is in a space in this BIM service center. Okay, so the software add information to the model. Okay. So for this, for getting the quantities of the building in the design stage, we can use Cype for designing the structure. We can also Cype also produce a BIM model of the structure. We can use Cype architecture for modeling the building only the geometry, 3D geometry. After that, we can use other software that are libraries of properties of the element to enrich the model, and we can use the last one in this workflow, that is open BIM quantities. Okay, I'm going to show you some of this. This is a structure. This software, Cype, is the most famous and most powerful software of Cype. This is the first one that they did. The person who write the code of this software is now retired, and the people who is still working in Cype, they can't change the code because it's the code is very personal. So they are doing the work from the beginning again. Okay, with other standard for programming or writing the code. Yes, when I knew that, I feel good because the code that I wrote is the same. Nobody understands this code, only you. And I thought that I was a bit so that I was the only one person who happened it to him, but so yes, I like to hear this history of this guy in Cype. Okay, this has a lot of windows, but the software can read the mechanical model and analyze the behavior, getting the formation, and also getting the internal forces, but not only. They can check. It can check the section, the resistance of the section, and many other things. Okay, and also can design the reinforcement inside the concrete beams or column with checking, and after that you can edit the final design, changing things, and after that it produces drawings with a lot of details. So it's a very efficient tool of Cype, and this is the core and the first one software of Cype. They produced tool for calculation, not for BIM. The BIM in Cype came later. Okay, another example is Cype architecture, that is the modeler. This is very easy to work. You can some windows here, some section for introduce element and even for introduce furniture inside the building. And this element has, for example, the wall have very few information, only the thickness, but not information about the material. The information about the material is introducing in this workflow with other software. Also, that is a library. So this is not Cype. This is not Revit, but if you use several software of Cype, you can do the same. Okay, with enrich the model with all the information needed, and needed for what? Needed for the thermal analysis and for the budget, for the bill of quantities. Okay, so this is structured in levels and in layers, and with different views in plans. Different views as Cype, the 3D, and also with layers to organize the information. You can selected or deselected the layers in order to have a view of what you want. For example, columns or this column and floors. And this in this software, as I said, the information, for example, for the slab is only the thickness, and the position and the geometry properties, but not the layers inside the floor. The layers is introducing with another software that is here mentioned. Is Open BIM construction system. That is a library. Cype CAD, this Cype architecture, and this is the library that I'm telling you, with a lot of kind of partition and walls. And the Open BIM quantities is a tool that I like much. Is this tool? So you have a database of prices that you can import in DC3 format. Okay, for example, this one. No, this one. No, it's this one, what I wanted. Okay, actually, in order to. Okay, it's a database of prices. This is a budget without the quantities. Okay, and you can produce this database of cost database with other software, with any software of budgets, and after that import here. And what you have to do here is select the database with prices. And okay, and here you have to join the element, select the element, and select the price or the unit, the work unit that you have in your cost database, and that's all. And then these green points means that there are elements in the model in the model linked with the database, price database, or the cost database. And final, in these windows, you have the bill of quantities or the budget. So, and it's nice to manage the model because you can you can see which part of the model is in the budget, in the bill of quantities. If you select one unit in your bill of quantity. For example, this is reinforced concrete flat slabs. So slabs in the roof and other slabs of concrete are taken into account with this unit in the budget. Okay, this was one workflow, and the other workflow that I would like to show you is about the other workflow. Yes, is this one that you also have to use several tools, prepare the modeler, another that calculate the amount of space of each part of each part of the building related with the use of this part of the building, and after that you have the Cype term E plus for reproduce this for doing this thermal analysis or energy analysis that is needed in order to check if the properties of the envelope, the properties of the windows and doors, the opening, and if this heating system and is enough according to the standard of each country. And I'm going to show you this picture because it's the interface of this tool, and it's easy. Even the energy analysis is a bit complicated. It's easy to understand that you need properties for external wall, partition wall. You need properties, thermal properties of slabs and roofs. You also have thermal bridges that you can analyze with this software. You need the uses of each area of the building, and also of each zones of the building, and also you need a location and weather properties of this location, and after that the energy system properties. And what you get is reports as results about the energy demand report that are linked with material properties and also energy consumption report, and to evaluate the energy efficiency of the building. So, and one thing that I like very much is that in this workflow, all the software are free. Okay, you can do that. So it's easy to know if our design meet the requirements about energy consumption that we have in the standard here in Spain is the Código Técnico. Technical code. Technical building technical code. Handbook. And this tool, Cype E Plus, is not. This one is not free. The Spanish version is free. Okay, but you can use this one if you link this software with a educational project in BIM Server Center, and in this way you can do that, not for professional works, but you can use it, and it's nice tools in my opinion, because all the concepts are in a very nice way to introduce data and to get results.
A question about the IFC. When you are using Cype, all the models save the file in the same format in the IFC always.
Each one of them has their own native format, but also save the information in IFC in BIM Server Center.
Yeah, but the problem that I have, I understand, or other place that exists sometimes the IPC it doesn't contain all the information that the original, the native.
Okay, but that's not this is not the problem with Cype, because all the program are from Cype, and the information that Cype store in the model is the information that the next software of Cype needs. So there is not the interoperability here is works because it's only Cype. And that's all. That's all what I wanted to tell you about Cype.
Okay, then we're ready for our presentation of Revit. But first, I would like to just get some feedback from the online viewers. Are you hearing my voice? Just give a thumbs up or chat. Perfect. Perfect. Yes. Then I think we will start. So first, I'll just have we're just going to introduce ourselves again. My name is Henrik Røed, and I am an assistant professor at Østfold University College.
And I'm Marius Spikla. I'm also an assistant professor at Høgskolen Østfold. And we both have a background working before we started at Høgskolen. We have worked as consultants for about 6 years. So we also have used the program as consultants.
In real building projects.
Yeah.
That was a bit about our background. And before we start, I have 2 questions for the audience. I just want to know, first question, how many of you have heard of Revit before? Raise your hands.
Yeah.
Yes? Good. And then second question, how many of you have used Revit before?
Yeah.
Okay, a bit few. In this first session, we will just give a brief introduction and if time, we will just show you maybe an example of a model.
Yeah.
So we're not going into very detail. We will take the details in the parallel session. Okay. So first, an introduction. We're just going to tell you a bit about what is Revit, how it is used, and at the end, what you can do with Revit. So what is Revit?
So Revit is a multi-purpose BIM software. We also have experience with Tekla in our work there, but mostly we have used Revit. And Revit is it's a multidiscipline tool that can be used to design and also used in the documentary. Yeah, you can use parametric design, and it can include both geometry and design and yeah, contribution.
Yeah, and the construction documentation. And of course, we use it, the software to the BIM process, and it's changing how we think, act, and design our future buildings by the use of model tools such as Revit. And what sets Revit apart from other software is the ability to you can model different multidisciplinary models and make it into one comprehensive model in the same software. So for instance, the architecture, the structural engineer, the MEP, mechanical, electrical and plumbing systems, all can design and model their model in Revit, and then you can put it together in one comprehensive model, or you can actually work in the same model at the same time. We're just going to explain a little bit about that afterwards. So what is Revit used for?
Shown in the slide, it's used for all the disciplines, both the architecture, the structural engineer, all the systems, and yeah, to complete the work. So you basically have the same program.
Yeah, you can see that all this can be modeled using Revit, and it gives you the opportunity to or the project planning process can be very streamlined and efficient due to this possibility. So what can you do in Revit? Well, what you can do is you get a realistic model of what you are planning to build or design and build. So you get a 3D modeling of the structure. And of course, the geometry shapes. Revit loves straight edges. So when you're just modeling straight edges, such as this example shown in the picture, it's very good. But you can also model different shapes using different tools in Revit. So just so you know that.
Yeah, so you can use parametric design
for instance. And of course, one powerful thing about Revit is that you can then include any type of information regarding each object. So for instance, window is an object, the facade is an object. Every piece of the building, it consists of many objects, and then you can give them information as to what you want to tell to other project members, for instance. And also then it is very good for collaboration, as I mentioned. Work sharing, you can either model on your own computer, local file, or you can create what we call a central model and start work sharing. And that means that you have one model that is loaded and saved in the server, and then you use your own local file which has your username on it, and whenever you make changes to your local, you work in your local model, and then when every time you do some changes and upload it to the central model, another user who sits in another place can get the latest changes. I've tried that, and it's very, very convenient if you have several project team members working on the same project. And of course, quantity estimation. You mentioned a little bit about it, but you can, by the use of what we call schedules, you can create a long list of different schedules as to what type of data you need for. It can be for research, or it can be for cost estimation, material purchase, and so on. You can. It's the list. The possibilities of making lists to export data from the model is endless.
Mm.
And a last point that I wanted to emphasize is not directly linked to Revit, but LOD, or the level of development. That's a term from BIM, and that can basically be explained as a way to show how a model is thought through in how well is the model developed during a project process. So for instance, you have a pre-design phase, that is one type of LOD. You have the design phase, that's one type of LOD. And then you have the quality assurance phase, that's one type of LOD. And then a construction phase, and then a as-built phase and maintenance phase, and so on. And each phase is then designated a specific number or a prefix or so on.
Mm. Yeah, I can add one more thing. It's not only the engineer and the architects and the people that works on the project that is using Revit. Also, the producers, for example, for doors, for windows, and also the furnitures, because the architecture like to add in all the objects, and for sure it will. It's easier to use object you can download. For example, a popular store in Norway and Sweden is IKEA. It's quite big with a lot of things, and there you can download Revit files of all the bed, all the everything, and you can place it in the model. And they do that to increase their sales, because when you see that on the architect drawing, you probably, and for the same as the producer and of doors and window, then you can find exactly what you can buy.
Yeah, the exact measurements and
Yeah.
the product data of each element. And also one thing I didn't wrote on the slide, but also mention is that when you start using Revit, you have this what you call it, default sets of components or objects. For instance, you have a wall, floor, a roof, and so on. And also some components, like Marius mentioned, it could be furniture or foundation, or and these are very limited. But when you start use Revit, you can customize your own objects.
Yeah.
So if you're missing some objects, either missing object completely, or missing another geometry of an object. For instance, you have a foundation that is 1 meter by 1 meter, and you need a foundation that is 1.5. You just make a copy and make another type. And then when you do that, you can expand your library so that when you use Revit, you have just the library of the content will increase as you use it. Yes. Then this is a picture from Norway, just to show you that BIM models are used at construction sites. Marius can tell.
So they call this like a BIM kiosk. I think this picture is from a hospital built near our school, and here the workers they set up in the building process big screens, and they can go in there. They can, for instance, if they have wonder where is the ventilation going, and instead of opening the wall, they can just click and check, and hopefully they replace it the same place as they should in the 3D model.
The 3D model
And
is
the same as
correspond to
all the electricity and everything. And usually they also place it at the same place, because in the project planning before you start building, you have this crash control. It's much easier to see when you combine all the models, if something have to be moved, or
if you have a plumbing or a pipe goes straight to your beam, that's not a good option. Yes. So just to sum up, today the design process forces much more multidisciplinary work and increased attention to building greener buildings. So the use of BIM models to do life cycle assessments, that's a possibility.
yeah. So the 3D model obviously represents and gives us increased understanding for all, so everybody can understand it. Yeah.
PhD or no PhD? Yes.
We have also some model. Yeah, thank you for
attention. Are there any questions?
Otherwise, we will show you some models if you have time.
It's time to show example.
I think I'm not sure if
No,
yes, you can show the model. We are now in a common assessment, but I'm thinking in beginning the parallel section after meal.
After meal, yes.
Maybe it's a good idea.
Yeah, I think we see the screen. So it works. Yeah. Okay, so last semester, me and Henrik make the students in one subject. We had a housing project, and the final result of one of the projects here, this building is made in Revit, and it's when you it's a realistic view, so you can it seems like it built because it looks real, but actually it's only a 3D model in Revit.
Yes. So this is how the 3D model when you export it, how it will look. But you can also then, as Marius showed, you can make a rendering so that you get a more realistic feel about how the building will be at the end. Now,
Yeah,
just
here is
show
the same model.
and in the
in,
model
in
window.
Revit. So here, and we have take out the site, placed it in the right coordinates in the world. So here you can, and we have model all the ventilation. It's a 4 housing project. You can also see the solar when you can place a date and you can see how is the sun. Yeah, we have also the car industry use Revit now, so we can we have some car in our garage. It's some nice cars actually. And the tree.
And
Here we also have a lifting. It's a police car.
this particular student was above average interested in cars.
Yeah. And here we have also added the reinforcement, so it's very easy to understand how you place the reinforcement because you can see it in 3D, and you get out all the links
because
for
in the construction industry, when me and Morris worked there as consultants, we also produced reinforcement drawings and formwork drawings. But when we started, it was also they also started to model the reinforcement in 3D, and then it's a much better way to see how the reinforcement will be placed inside the different elements of the concrete.
There is some example.
And then, of course, you can model both when you have just the other one first. Yes, you have just a regular slab, and then you can see the bøyle.
Yeah.
I'm not sure
That's the
Norwegian word. And of course the longitudinal reinforcement.
Yeah.
And also the other example is that if you have a more complex shape, for instance, a retaining wall of some sort that has a curvature or a different cross section along its path, you can also schedule the reinforcement. For this type of reinforcement, it just gives you a representation on how it is, but again, it's better to see how will the construction be finalized. See it a 3D visualization before it is actually constructed. It's a very good way to understand how it will be. Yes.
This will reduce the reinforcement, or I mean, when you want to enter the reinforcement,
yeah,
the patient, for example, or for the slab, you have to do the work part for each part. I guess not.
No. No. So a question was that can you use it to replace rebars? You have to use, as I understand it, did you have to, how would say, put out one rebar at a time? No. If you, like, for instance, a slab like that, if it's just 4x4 or 100 by 100 or 100 by 50 or something, it will take the same amount of time to to model the reinforcement and give it precise information. You just use, because of the tools available in Revit, you can you can automatically distribute the reinforcement in the spacing that you choose, for instance.
We find Tekla easier for doing this work, or
I haven't personally. I've tried Tekla. I haven't personally tried the reinforcement, but I would, from what I've heard from other former colleagues, when you learn how to use Tekla, I would say it's about as good, and even maybe a bit better, because one issue with Revit is the way to schedule mark the reinforcement. That's a bit tricky.
Or maybe 3 years ago, I think Tekla was ahead of Revit. Yes. So, in my opinion, I use both. I think Tekla is better on steel detailing joints, and also if you like hollow cores and concrete elements used in production. And Revit is better in the cast in place concrete
yeah.
And also have it's easier to use for architects, and it's the same program, so it's
they can use the same program, of course. So that's also an advantage by using that.
So it's quite cool.
I think then we didn't have anything else. Are there any more questions before we? Yes.
Can you make, for example, if you had I guess concrete ceiling or something like that, and when it's the reinforcement, can you make some floor plan generate from the 3D model?
Yes.
Yeah.
You so how the design process in most of the consulting business, or those who do 3D modeling, the normal process is that you make a 3D model, and you use that for design and to clarify with other disciplines. But the final product often is drawings. So when you have built up a model, you have levels, and then you can from that get plan views, section views, callouts, whatever you want, detail views, whatever you want. So you don't have to make like the 2D views from scratch. They are there because you have built up a model.
Yeah.
It just takes some time to build a 3D model, but then you have the 2D.
But when you build a 3D model, you actually draw in 2D, and it will be 3D.
Yeah.
So
we will, for those of you interested and will participate in the Revit session, we will start by showing you how you start a Revit project and how to model objects. Yes.
thank you.
Yes. Thank you for your attention.
So, can we start again? I will say some, show you some examples of structures detailed in Tekla, and one of these is 30 Hudson yards. It's a super tall skyscraper from New York that won the Structural Engineering Award of Excellence in 2022. It's the biggest project done in Tekla. The model has over 750,000 elements. For this was used model sharing with a number of 112 users. Yes, a lot of users. The total cost for this building was over $20 billion. The height of the building is 392 meters. Total floor areas is 240 square meters, was designed by architect Kohn Pedersen Fox and structural engineer Tonton Tomasetti. Another project is the landmark 81, Vietnam. A building with a height of 461 meters. Floor areas nearly the same, 241 square meters. For this building was used 275,000 cubic meters of concrete. Museum of the Future from Dubai. It's an exhibition space for innovative and futuristic ideologies, services, and products located in Dubai. It's one of the most complex structures. The Museum of the Future was designed by Kila Design Architecture Studio and engineered by Bureau Apple. The Shard from London. It's an unusual structure with a concrete basement, structural steel from ground to level 40, concrete from level 41 to 69, and steel again from there to the top of the level 95. The whole structure is given stability by a massive concrete core that is placed in the middle of the building. The height of the building is 310 meters. The structural engineer is WSP Cantor-Sinuk, and the architect was Renzo Piano. The Laminary, Finland. Judging by its architectures and appearance, Laminary is a uniquely tall and high-class complex of apartments and business, offices, and parking space. Marina Bay and Art Science Museum from Singapore. The resort was designed by Mose Sarti, and the structural engineer was Arup. Piron Tower, a commercial skyscraper in London. It stands 230 meters tall. It's designed by Kohn Pedersen Fox, and structural engineer was handled also by Arup. London City Hall, another building. It is an unusual shape for a building. There's a lot of jokes about this building. Also, Boris Johnson said, I will not say with the words that was compared. You can find or on internet. Was designed by Norman Foster, and the structural engineer was done also by Arup. And let's talk about Tekla structures. The 3C for Tekla structures means constructability. You can design and build any kind of structure. You will have the highest level of detail, and also solutions for the entire design cycle. For the collaboration, Tekla offers a better visualization and simulation among participants, an open approach to BIM and IFC, and also advanced teamwork possibilities. The client gets a program adapted to local requirements, the possibility of developing personal applications through the open API, and also, of course, local and online support. The workflow in Tekla described in this table start with design and modeling, what it means import modeling detailing. After you finish the detailing, you'll check clashes for the structures. After this, you'll get documents, what it means drawings, rebar drawings, detailing drawings for steel structures. You can export model to use planning for construction, for products, and also for assembly. This is Tekla from concept to the construction site. Okay. Design and modeling start with importing the model using different kind of import method. You can use CAD references, algorithmic modeling. You can import a 3D model, point clouds, 2D, 3D CAD reference, IFC reference, and conversions, any kind of file formats that you can find. CAD reference, 3D polylines and 3D CAD objects can be imported. You can have an interactive link to Rhino, Grasshopper. You can import 3D models, 3D geometry from CAD, from SketchUp, architectural programs, and structural design programs, software. New and import of point clouds. Tekla offers ability to import scanned information. For this, you can use all main file formats. It's important to have the right position, the exact position for the existing machinery systems. And also you can check the execution to the model. Design and modeling. When you start to model, you can model the geometry, or you can use parametric profiles and curves. In the software, you will find all known structural elements like piles, foundation, gears, slabs, walls, parametric and curve profiles in two directions. After obtaining the 3D model, starting the detailing of the structures. That means detailing of the rebars if you design reinforced concrete. You can detail post-tensioning. You can detail steel connections, components, formwork, and scaffolding also. Some example of rebars modeling, reinforcement concrete in Tekla. Different kind of structural elements, columns, beams. You can detail rectangular columns, round columns, a lot of different kind of beams. Different kind of rebar methods. Can detail the foundations. Fittings for stairs. Detailing for embedded parts. Post tensioning, that it means here was a short video. Doesn't work in PDF. Can model and detail the post tensioning, tendons, hollow ducts. Also the steel joints. The steel joints you can choose from library directly. It's a lot of typology of connections, or you can create any kind of joints connection you will need in your model. Some examples of steel joint details. You can detail welded tube connections. And also various components, complex elements like parapets, curves, handrails, or steel stairs. Also, you can use parametric components. You have the possibility to create your own type of elements. This can be customizing the program and definitely will improve the designer's work speed. Can model formwork. They have Doka and Perry. Works. I'll give you the presentation and the videos of that. For the scaffolding, doesn't have a specific tool, but you can model every single material like a timber. After detailing, you will do the checking of the clashes. You can detect the clashes between reference models and parts, reference object and parts, parts versus parts. This is important to see if you have the concrete coating, if you have the cover thickness to concrete, if you have clashes between parts and here was also a small video. About the documentation that you can get, you'll get, of course, rebar drawings, execution plans. If you will detail and design reinforced concrete structure, or drawings of steel structures executions, are designing in steel. An example of rebar drawings. This can be used, and you can have different, for the same model, you can have different output standards for the drawings. Also, you can have assembly instructions. Drawings for steel structures. If you have to use the same element, you can clone in Tekla, and you can use after this save time. Of course, you will have all kind of material list for bending rebars, bill of quantities for steel parts, and everything that is inside. You can export in any kind of file format and use in other softwares. Actually, you can import and export all imported standard formats in Tekla. Has also a link with project management software, and can be used in project management for planning the construction. And to use the production and assembly. Have a direct connection with the CNC machines. Gives information for shaping fittings, welding of rebar housings. And more information about Tekla you will get after the break. We'll have a detailed presentation how you can do things in Tekla. Normally, to learn software like this, I think everyone can understand. It's not. You'll need more than 2 or 3 hours. Normally, a few days to start to use a program like this, to understand. So we will show some tricks, some things to. Okay, thank you for your attention. If you have any questions.
To build the model of structure, it's a lot of design the model.
Yes, a lot of details. In my opinion, it's a software that works very good in steel detailing. We use this software not only for steel detailing. By the other hand, it's not a cheap software.
But-
And also,
But there are personal reasons.
yes, it's possible to have educational license. And our students have possibility to get educational license and work in Tekla.
Okay, so thank you. I think